Good morning, everyone. I'm honored to present here our work at the University Hospital of Grenoble, Alpes in France, reported in a paper entitled Hypergraph-based data model for complex health data exploration and its implementation in PredImed clinical data warehouse. In the current context, PredImed is an operational clinical data warehouse gathering information concerning 1.8 million patients treated at Grenoble Alpes University Hospital into a structured data lake since the French General Data Protection Regulation Authority, CNIL in France, authorized the operational phase of PredImed within the defined medical legal framework in October 2019. In response to the objectives of physicians and medical experts, we have designed PredImed to allow it to be explored in the most interactive possible ways, making it easy to visualize the complex, highly connected, and massive information it contains. From the engineer's point of view, we had to answer these two essential questions. How to provide real-time and user-friendly tools suited to massive and complex data for non-IT users. How to deal with information variability over time. For the conception part, methods consisted first of all in modeling the information that the data lake has to gather with medical experts since the beginning of the project using the hypergraph-based data structure method, which is referred to in the paper and that we'll describe next. Our approach is to use then this data design as a framework for implementation to minimize source code modifications as the data lake structure evolves over time. Last, we have designed a layered software architecture for information processing, relying whenever possible on so-called in-memory software bricks to provide users with the most interactive features possible. We have opted for a hypergraph-based data model that allows us to clearly represent the complex structure of concepts at different levels, nodes of the graph, their semantic relations, edges of the graph, and attributes, as close as possible to their intrinsic meaning in the health domain. As a preliminary result, this evolutionary named and directed graph of concepts and their relationships of interest and attributes represents the Suga Hospital Clinical Data Warehouse model. The model shows, for example, organization of the information describing patients who have come to the hospital and have undergone various types of examination tests that have been prescribed, which have produced documents of different types, biological, imaging, or clinical types of documents such as weight, height, and for which a set of diagnostics could have been established which concerns these patients. We also considered that the data structure presents a variability in time. Therefore, the flexibility of the chosen solution appears to be a key point to avoid having to regularly rewrite the platform code. In this layered architecture scheme, the information extracted from the source databases layer on the left is reshaped according to the target data structure defined at the PredImed data model design level. This information is then routed into the structured data lake central layer and made available to applications in the user's accessible data expression layer. These applications allow the user to navigate first and explore then the information contained in the databases and even to elaborate his own data according to the specific point of view of his medical domain. One of the key points is that the structured data lake has to be efficient to answer quickly to potentially complex queries concerning highly connected and massive information it hosts by dealing with the applicative user layer. This is why we have chosen to rely on microservices at the heart of the data lake, able to share the Predimed functionalities we have developed with the bricks of the application layer for allowing the expression of the information. For the implementation part, we have chosen Talent Component to extract information from source databases and reshape it to provide the expected graph modeled collections of edges and nodes and their attributes to the NoSQL RongoDB property graph database. We are using native, flexible JSON data standard in the property graph database, allowing to describe each data node of a class or edge instance of a relation with its own specific attributes if necessary. For example, a new kind of result document that would be provided by a new kind of medical test. This JSON flexibility makes it also very easy to exchange with other software components using RESTful web service. Thus, we've developed into RongoDB a central Predimed API sharing applicative features for software components shown in the data expression zone, Predimed Data Lake Navigation module, Elasticsearch for data exploration module based on standard Lucene library, and Kibana for data visualization with dashboards, Predimed Patient 360 visualization module, as well as Predimed web mapping module and data elaborations Python scripts. Each applicative component of this layered architecture is a free-to-use version, and each of it could be easily replaced if it was needed. Predimed Data Navigation module allows graphic navigation within the clinical data warehouse graph model using successive hops from a set of selected elements to a node concept to another one following their edge relations. This is useful for selecting in a few minutes, for example, a multi-criteria cohort of patients based on their diagnosis, drug prescriptions, demographics, and textual imagery reports, which can usually take several months together with a conventional information system. At any stage of the path traversed in the graph, the sets of objects being selected in the current concept class can be projected on user demand in a search engine to explore its content and visualize it with a dashboard designed to represent objects attributes of its class. This is the cipher-like structure of an elementary traversal expression used to jump from a set of selected objects belonging to a graph node concept to the objects they are connected to in another node concept. For example, diabetes comorbidities for a patient older than 45 can be gathered within a few seconds using the following path in the graph. This is an example of interactive dashboards containing statistics description for currently selected patients during data lake navigation. Information such as demography statistics, blood types, spatial localizations, clinical events, and can thus be accessed in a few seconds. Here is another example of interactive dashboards containing statistics concerning the current drugs treatment selected during data lake navigation, using ATC codes, chemical names, and administration routes on the middle right. This is another last example for interactive dashboards for exploration of selected ICD diagnostics with ICD codes and full intitulate description. Last but not least, we can also exploit accurately the content of a group of patients with a complete synthetic view gathering for each patient, all available information in the data lake such as diagnostics, textual reports, contents, drugs, prescriptions, and specific trajectory through hospital medical departments. Predimed API provides also Python API toolkit to elaborate information describing patients' clinical trajectories as a Sankey graph, for example, composed with user-defined events and phases associated with their temporal alleles relationships. As results, as expected by the medical experts, PredMed provides interactive navigation and exploration ability to see physicians within 100 million of complex and massive information concerning about 1.8 million patients over the last 15 years. Ability to express a complex query as a step-by-step path in the graph. Data elaboration ability, data design based framework. As perspectives, the main development axis of PredMed concern enrichment of the data model in response to the need of projects using the PredMed platform. Developments of functionalities for the elaboration and analysis of patients' trajectories. Interoperability framework development. Generalization of the use of the PredMed platform at the hospital, which is already in progress. For conclusions, clinical data warehouse PredMed empowering physicians to explore, visualize, and qualitatively analyze interactively the complex and massive information of the patients treated in Chuga Hospital. Hypergraph-based model and its agile implementation allow for easy data structural changes inherent to the evolution of techniques and practice in the health field. This flexibility provides adaptability to the evolution of interoperability standards. Thank you, and we warmly thank all the medical experts and engineers involved in Chuga's PredMed clinical data warehouse to make it constantly progress.